All right, good afternoon, everybody. Woo, thank you. I like the excitement to get started. I'm Simon Perryman, Technical Evangelist with Microsoft, and I used to spend about 4 years on the cluster team, so I've been kind of passionate about designing high availability solutions, being able to use them, and this session is going to talk about how we go and extend System Center and maintain high availability for System Center itself, as well as our services and applications that we're running in our data center. I'm also joined today by Anna, who's one of our MVPs from the cluster team, and also a regional team lead with concurrency. He's going to be helping me out with the demos today. Now, our goal here with System Center 2012 is really to deliver IT as a service. Provide fluidity. This is kind of our Microsoft private cloud vision. And you're going to see us, as part of this presentation, break down how we maintain high availability, how we talk about System Center 2012 into 3 main capabilities: our application management, our service delivery and automation, and then our infrastructure management. And so we're going to talk about maintaining high availability across all 3 of these different layers. So let's take a look at the self-service model that we use with System Center 2012. Now, our goal here is to really improve this relationship between our developers and our infrastructure specialists. I'm sure if you've been to the keynote, you've heard a lot about DevOps throughout the week. And so we're still trying to really help enable our developers, help enable our infrastructure specialists, and just provide more fluidity throughout the data center. Now, the key components that we think about with System Center 2012 are, first of all, self-service. Now, with self-service, we're essentially offering our application owners, our developers, our non-infrastructure guys, the ability to make any type of request that they want. They need a service. Go to a self-service portal. An application is offline. Go fill out a form. They have any type of problems with the service, with the data center, they could go make a request to IT. Now, all of these requests are put in what we call a service model. Think of this as just a standardized template. Fill out a form. This is the problem. This is my name. Let me know when you fix it. And so part of our whole goal with the System Center is to provide standardization. Now, standardization is really important when we try to move to this model of private cloud because it ensures consistency every time. When you deploy a service, we want to deploy it the exact same way every time, consistency. That's going to eliminate configuration challenges, and it's going to stop wasting time. You know, humans make mistakes when they deploy things. If you're going through a 50-step checklist when you go and set up a multi-tiered virtual machine, human error happens, right? People make mistakes. By providing standardization, we can ensure that the same service gets delivered every time. And this is important towards high availability and continual availability because it eliminates all types of configuration errors. Now, when an end user says, hey, I want this type of service or application, or hey, I need to go and report this type of problem, we're going to go and automate the resolution. So if they say, I need this service, we automatically deploy it. They say, hey, I have this problem, we can automatically fix it. But again, it's still standardization every single time. We go and push our services out to the clouds. That could be your public cloud, your private cloud, your third-party hosted cloud, physical environments, virtual environments. We support all of these. But then most importantly, after it's up and running, we have to remember that we need to monitor and operate it. It's not just good enough pushing it out there, getting it up and running. We need to ensure that it stays online. If it crashes, we know about it. If it crashes, we can automatically resolve it. And we're going to walk through all of these different System Center components today and show you how we go through this end-to-end workflow, looking at our infrastructure, our services and automation, and our application management. First thing we're going to talk about, though, is actually providing high availability for System Center itself. So all those different System Center components, what do we do to keep System Center online and running? Remember, System Center is critical to running the rest of our infrastructure. So if System Center is down, we're going to have challenges detecting problems, deploying services. So it's critical to keep your System Center infrastructure online. After that, we're going to go through the 3 different layers of automation. And finally, we're going to talk about how we can extend our continual availability goals with Windows Azure, doing things such as backing up to the cloud using Data Protection Manager. Well, let's get started with System Center high availability. First of all, you guys probably know this already, but System Center is no longer sold as a bunch of individual products, right? You get System Center 2012, you get everything inside the packet. Now, this is important because this gives you the ability to go and try automation, to try self-service. If you buy System Center, you get all of these tools at your disposal already. So you don't have to worry about separate licenses. If my boss approves a budget to be able to use these, you have System Center, you get all of these components today. Now, first to a virtual machine manager app controller. Very briefly, VMM manages our virtualized infrastructure and fabric, network, storage, and it also manages third-party hypervisors, Citrix and VMware. App Controller is our self-service portal, a web-based interface where we can isolate a particular user, give them access to particular services, templates, infrastructure, and enable them to be more sufficient in deploying their application. Heck, maybe the developer notices their app's performing slowly. It's the weekend, the infrastructure guy's at home. Well, if there's a self-service portal, your developer can actually go and scale up the service themselves. They can help themselves keep this continual availability online and running. Next two components are Operations Manager and Data Protection Manager. Operations Manager is used to monitor our entire infrastructure, from the storage, networks, individual server components such as fans, through the actual boxes, the servers, the host operating system, guest operating system, virtual machines, and even those applications running within the virtual machines. We have end-to-end monitoring throughout the stack. Data Protection Manager is used to back up and secure our information. You could back up running virtual machines, and you can even do that during live migration. So you don't have to think about, when am I moving my VMs? A server crashes, will things be backed up? DPM in 2012 protects during live migration, cluster shared volumes, anything you need. Next two are more around our services and automation layer. Orchestrator is our automated workflow engine, a nice simple drag and drop interface to be able to automate pretty much anything in a data center, so long as there's a programmatic interface. You have APIs, function calls, script, PowerShell, VBS scripts. You could go and integrate anything within Orchestrator. So one of my most unusual examples is we have a customer and they have faulty fans. They have a particular piece of hardware from a vendor and the actual fans that keep the systems cool crash. Well, they've deployed a management pack that monitors whether the fans are working. It speaks to the BMC inside the server. Whenever these fans crash, which is every month, once every 2-3 months, a ticket, Operations Manager detects it, creates a ticket, and it will automatically order a new fan for them, so they get it shipped to them within a few days. So the admin doesn't even have to think about, hey, is my server going to go offline? Is the fan unhealthy? It's an end-to-end process now, freeing up time for our IT pros. Service Manager is our IT help desk ticket system. It allows you to track incidents across the data center, but more importantly, it's tied in with all the other System Center components. Operations Manager raises an alert, it's ticketed in Service Manager, and then Service Manager can go and kick off an automated resolution. So let's say you have a website that crashes. Operations Manager detects it, opens a ticket, the ticket then automatically tries to resolve it using Orchestrator. So great integration across the products. Final two are Configuration Manager and Endpoint Protection. We're not going to spend really any time on these whatsoever, but these are used to secure the environment, protect it from malware, keep the environment healthy. Now, there's one other System Center component that's getting more traction, a little more popularity, but does not come with 2012, and that's System Center Advisor. It's a free online cloud service. You could just go to systemcenteradvisor.com, download it. It will go scan your entire environment, tell you if you're not following any best practices, things that could cause service downtime, could have problems with your online and continual availability. So a great free online tool to just ensure you're following best practices. So let's talk about how we keep System Center online and running. First of all, server availability. So this would be for your VMM management server, your operations management server, all of those key management server components. First of all, deploy redundant services, right? You still need to patch a host, you'll still need to patch the guest operating system within a VM. So redundancy is key. Always eliminate any single point of failure. The second option you have is running this component inside a clustered virtual machine. So you have mobility, you can move the VMs. If the VM crashes, the cluster will detect it and restart. So you could have availability just by using basic Hyper-V clustering and running that service inside the VM. And every single System Center component is supported while running inside a VM, including Virtual Machine Manager. You want to use backup. Make sure that those databases and those services stay online. You could use backup with DPM. Or if you're using a virtual machine, you could use the Hyper-V replica technology and actually replicate that entire VHD file to a second data center. You can even have data center high availability with System Center. And then, of course, basic monitoring, right? Make sure that it's healthy. Make sure that that entire server isn't being overwhelmed by other applications or processes. So deploy the management pack, monitor that VMM server or that other type of server. Now, System Center 2012 always has a database. That's where we store the detailed information. So let's say you're using Virtual Machine Manager. Well, we need to keep track of your hosts, your services, your networks, your IP address pools, your users, security, permission. All of that's stored in a SQL database on the back end. Now, SQL has a great high availability solution, especially with Windows Server 2012, SQL Server 2012 always on. So you can actually cluster your back-end database, make sure that stays online, make sure that stays available. SQL also has replication across multiple sites, so you can replicate all of that data from your primary site to a secondary data center. That's all built into SQL as well. Then you have the other kind of three more traditional high availability solutions as well. Run it in a clustered virtual machine. Back it up or replicate it. Monitor it with a management pack. Now, System Center 2012 also has different unique high availability solutions for each of the different components as well. So I'm going to briefly walk you through those. First of all, System Center Advisor. This is the free online service, but it's based in Windows Azure. Azure supports geo-redundancy. We have dozens of data centers around the world keeping the service online. So System Center Advisor, always highly available since it's running as a cloud service in Azure. Now, several of the different System Center components have a web-based interface for management, so people don't have to go and install the entire management server. This includes App Controller, Orchestrator Web Console, Service Manager Service Catalog. And for all of these web-based consoles, you can use network load balancing. Deploy redundant services, load balance the traffic between them, so a single server is never overwhelmed. The Operations Manager Management Service has a concept called highly available management groups. Now, essentially what you're doing here is having multiple redundant Operations Manager servers. One server is a primary. The other servers are loosely monitoring it. And if that primary crashes, becomes unavailable, one of the secondary servers will be promoted to the primary and continue monitoring and reporting on the environment. So you have kind of it's not quite a failover, but it's kind of a redundancy and promotion system happening within Operations Manager. Orchestrator has a similar solution as well. They have redundant services that can be deployed, also monitor each other, and can promote each other as well. So if your primary runbook server freezes, becomes unavailable, a secondary runbook server can come online and continue running your automation activities. Virtual Machine Manager also has what are called library servers. These are basically storing your VHD files, your ISOs, your templates, all the different Virtual Machine Manager components that you may want to go and deploy when you're deploying new virtual machines. That library is basically a file server, and that can be clustered just like traditional file server clustering, made highly available, up to 64 nodes if you really want to. And then finally, the VMM Management Server. With Windows Server 2012, you can now actually install the VMM Management Server directly on a failover cluster, directly on the bare metal, just like you would with a traditional file server or a traditional SQL server. This means that it's being monitored by the actual cluster service underneath. If the VMM service crashes, it will be restarted. If the entire host crashes, that VMM server will actually fail over to another cluster node. So it's a direct first-class citizen running on top of a failover cluster. So that's going to give you the best resiliency, best availability for your VMM server. Now let's move on and talk about our infrastructure components, how we're maintaining the availability throughout our networks, storage, and different pieces of our fabric. First thing we want to think about with high availability is always using failover clustering as essentially our default availability solution. Now, failover clustering with Windows Server 2012 supports pretty much every single Windows Server workload. Now, there's a few exceptions of solutions that could work on a cluster, but are actually recommended to use with network load balancing because having a redundant service is better in those cases. So that's usually IIS and direct access. For the most part, every other different server workload, file, DHCP, print, DNS, all of these different things can run directly on a failover cluster. So think about failover clustering as kind of the basic foundation you need in your data center. But as your data center scales, you're going to be managing tens of clusters, hundreds of clusters maybe. And so this is where you want to think about using Virtual Machine Manager when you need that scale management. VMM is now tightly integrated with Windows Server failover clustering. You can now not only manage a cluster, but you can validate a cluster, deploy it from bare metal. We'll talk about that shortly. We have the ability to scale up, and each cluster can now manage over 8,000 VMs, over 1,000 VMs per individual server, fully supported with what we have in Hyper-V 2012 using VMM 2012. And it also supports all the new types of live migration that came with Windows Server 2012. So traditional live migration, storage live migration, where you're moving the VHD file. Shared nothing live migration, where you're simultaneously moving a VM and a VHD file between two individual hosts. All of that can be managed and operated using Virtual Machine Manager. So let's talk a little more about the bare metal provisioning. Now, bare metal provisioning, this means you literally have a brand new server, gets dropped off at the data center, you plug in redundant internet connections, no single points of failure, redundant power connections, no single points of failure, turn it on, and Virtual Machine Manager can detect it, install the operating system, configure it, install the Hyper-V role, install the failover clustering role, and actually add it to a cluster, just using a few steps. Now, the way that this works is every server has what's called a baseboard management controller, or BMC. It's kind of part of the BIOS. Think of this as almost like a mini operating system with limited functionality. What we can do is VMM will actually go and communicate with the BMC. It will give it a temporary IP address. And then once it has that connection, it could go and tell it to do things such as assign storage, join a network, install an operating system, install different clustered roles, install the cluster feature, add it to an existing cluster, and validate the configuration to ensure that it's fully supported. Now, all of this can be done using Virtual Machine Manager. But we wanted to scale up beyond just having Hyper-V. We now have great support for VMware and for Citrix with their latest versions. Now, I don't even need this. Guess the internet's not highly available, huh? So we're multi-hypervisor support here. Now, one caveat. When we're managing Citrix, we can directly manage the Zen servers. We could go communicate with them, say do a Zen motion, distribute the resources, no problem. When we're managing VMware, we still have a dependency on vCenter. The reason why, the individual ESXi hosts, they don't have open APIs that we can directly communicate with. So we actually go and communicate with the vCenter server as an intermediary. That vCenter server will then go and actually tell the individual ESXi hosts, go perform a vMotion, do DRS, storage DRS, things like that. So just always keep that in mind. We still have that intermediary there. But for day-to-day management operations, redistributing traffic, deploying VMs, deploying services, deploying applications, fully supported using Virtual Machine Manager. Now, load balancer support is also built into Virtual Machine Manager. Now, load balancers help us just distribute traffic, right? Important for high availability so a single server or service doesn't get overwhelmed by too much network traffic. Now, there's built-in load balancer support by a lot of the major load balancer vendors. F5, Citrix Nextscaler, Big Iron, Brocade, so a lot of different partners that are built in. Now, there are two different types of load balancers that you're going to consider in your environment. In the past, everything that was really good was a hardware-based load balancer. Now, as we start to move to this highly virtualized environment, we've realized that, these hardware-based load balancers, they're expensive. They're hard to deploy, and oftentimes, they need some physical intervention where you're actually wiring the cables together. So with this past release, a lot of our load balancer partners have released software-based versions of their load balancers. This is basically a virtual machine that contains the same logic, routing logic, traffic measuring logic, different protocols that their hardware-based solution has. But you actually don't need to physically touch anything. Everything is wired up virtually using our virtual networks, virtualized storage, virtualized load balancers. So great solution to just easily deploy this, easily integrate it, to provide load balancing throughout your environment. Now, you also have the ability to pre-configure what type of load balancing traffic you want. All of this can be done as part of our service templates. So when I go and deploy a new service, I say, I need a load balancer here, and I get to configure some of the properties on it. And we're going to see that shortly as well. We have a great demo showing some load balancer integration. Now, Virtual Machine Manager also helps with our placement logic, distributing our VMs across our different hosts, keeping them online. Now, one challenge that we heard from a lot of customers, if they have lots and lots of Hyper-V hosts, they're constantly moving their VMs around, is what's the best host to go and move my VM to, right? If I have 100 hosts, I can't go and literally look at 100 hosts, figure out what has the most free memory, what has the most free network, what has the most free disk I/O. So we created this process called intelligent placement, and you can actually customize what host setting or settings are most important to you. So maybe you have a high-end SQL database. It needs a lot of disk I/O, and so you always want to move that VM to the host with the most free disk I/O. Well, it will constantly be scanning your entire environment, figuring out which is always the best candidate for you to move that VM, and anytime there's a crash, a failure, an automatic rebalance, or even a manual rebalance, it will go and automatically pick that best host for you based on your own customized settings. Now, in this release as well, we added what we call update management. Cluster patching is painful, right? Especially now with Windows Server 2012 when we scale up to 64-node clusters. Think about what you have to do when you patch a cluster node, right? You pause the node so nothing will come onto it. You slowly drain it by live migration. You know, live migrate this, live migrate this, live migrate this. You apply the patches. You reboot. You check for dependent patches. You reboot. You then make sure that the patch is installed successfully. Unpause it. Move all those workloads back on that host. And then repeat that another 63 times. I mean, patching in the past was painful. So also in Windows Server 2012, you may have heard of cluster-aware updating. This feature is very similar. With this feature, we go through a process of applying a baseline to a cluster or a group of servers, figuring out which patches are needed, pausing a node, automatically draining it, apply the patches. After the patch has been applied, first we check that the server is rebooted. We check the patch installation code returns as successful. We check that that server rejoins the cluster if it's part of a cluster. Then we say the patch is successful, move on to the next node in the cluster, and continue this cycle. Now, it gets to the point, if you have a 64-node cluster, you've got to say, am I constantly in a state of patching? Is that possible? We have new patches that come out every week. I have thousands of VMs that are constantly live migrating. And we now actually see customers using this that are almost in a continual state of patching. They're patching 24 hours a day, 7 days a week. But for them, it doesn't matter. Their environment is so fluid. Things are just moving around, back and forth, no downtime to the services and applications, yet their entire infrastructure stays healthy. Now, patching with Virtual Machine Manager. You can patch anything that VMM manages. So this is clusters. Let me clarify, Microsoft clusters. This is standalone Hyper-V hosts, Pixie servers, library servers, including library clusters. Basically, anything that VMM can see, it can go and manage this patch cycle. But I often get asked, we also manage Citrix Xen servers. We also manage VMware ESXi hosts. Can we patch them? We do not patch them, actually, because they don't use Microsoft Update, Microsoft patches. We don't understand the type of installation codes, how we pull down those patches. So this is patching for the entire Microsoft infrastructure here. Now, dynamic optimization. This is our automatic load balancing solution. And this is load balancing our VMs across different hosts. Now, essentially, what we're doing here, we're constantly monitoring our entire environment, looking at all of our individual hosts, seeing how many VMs are on them, what type of memory utilization, network utilization is happening. Now, if they reach past a certain threshold, we'll go and live migrate it to a different host to help distribute the traffic across all the different servers. Now, don't just think of an individual server getting overwhelmed with memory because there's too many VMs on the host. But if there's too many VMs on that host, there's going to be problems with disk I/O from that host to the storage, problems with network I/O from all those different connections coming into that single server. So having this distribution is important, but having it done automatically just makes things easier for you. Now, with dynamic optimization, it's actually configurable how aggressive you want it to be. And what aggressiveness means is how frequently do you want to try to load balance the solutions. So if you say I want it to be very aggressive, you're going to have a lot more live migrations, but things are going to be very, very, very even across all of your services. If you say it's less aggressive, it's not going to load balance as much, but you might have some slight differences in the number of resources across them. So it's kind of up to you, how important is it to have things completely equal versus the trade-off of this network traffic, live migration traffic that's happening. Now, when it does all of this, it also uses this intelligent placement algorithm that you got to customize. So when it goes and says, hey, this host is being overloaded, I'm going to go and move my VM somewhere, it picks the best host based on those settings that you've specified for disk I/O, network I/O, CPU, memory. Now, you can take this a step further by using what's called performance and resource optimization. This has been around for a couple releases. Now, it essentially does the same thing as dynamic optimization. When you reach a threshold, it will go and redistribute and load balance the VMs. The key difference is, using performance and resource optimization, you can use any type of metric, any type of alert, any type of threshold that Operations Manager can see. So it's not just looking at network, storage, memory, disk. You could say, hey, if there's too many users logged onto this particular service, as long as Operations Manager can send an alert, we can then go and load balance it. So think of this as almost extremely customizable dynamic optimization. So as we look at the animation here, we get an alert. Operations Manager reports a problem. It will tell Virtual Machine Manager, go move a VM. Virtual Machine Manager will still use that intelligent placement algorithm, that customizable algorithm, and redistribute the traffic to avoid these hosts getting overload, to allow you to continue having continual availability in your system. Now, as we move over to Operations Manager again, the connection here is that Operations Manager allows you to get much deeper insight than previous releases. So in the past, we could monitor a service, right? But if you think about the composition of a service, there's lots of different things happening there, right? You have the actual service that's running inside a VM, but then you have the VM. Then you have the host that's running the VM. You have the virtual disks. You have the virtual networks. So what we try to do in this release is really be able to break down this service, open it up to the different components, and be able to show you monitoring of all of these components simultaneously. So if a service isn't working, you could go to a dashboard view, break it down, and really try to drill down and isolate what part of this service isn't working. Hey, you suddenly realize it's a particular VM, a particular VHD. That makes it much quicker for you to figure out the problem, to go isolate it, to go fix it, and this in turn will give you higher availability because it keeps your service online longer. Now, we don't just do this for the infrastructure or just for the services, but we also do this for our networks as well. Operations Manager has a feature called Network Vicinity Dashboard, which is this view on the left. Basically, what happens when you install Operations Manager from the management server, we go and figure out what are all the connections to this server, the routers, the hubs, wireless access points. Then we run a recursive algorithm, and we take a hop out, figure out what's connected to those, do another recursive hop again and again and again. And using this algorithm, we can actually build a network topology diagram showing you everything in the environment, even including your client endpoints, such as servers, printers, wireless access points. Using this, you can actually quickly identify when there's a problem. It gets highlighted in red. So if you say, hey, something's not communicating with my service, open the diagram, and rather than having to worry about network traces, you can quickly identify where the problem is, which will help you fix it sooner, which will help you maintain continual availability using System Center. Now, Operations Manager isn't just focused on managing our Microsoft products as well. We have broad cross-platform visibility. We monitor literally anything, and if we don't support it with a built-in management pack, guess what? Operations Manager is fully extensible as well. You can create your own management packs. Pretty simple, pretty straightforward. So this means you don't just have to monitor Microsoft products or your services or your hardware. You can now monitor, partner products as well, VMware. But beyond that, you can monitor your own line of business applications. So you have a custom enterprise application. You could build your own management pack. You can assign different metrics, variables, performance counters that you want to trace, set thresholds. If one of those performance counters passes a threshold, Operations Manager will send an alert. So just keep in mind, System Center is highly extensible, highly customizable. Now, we talked a little bit about network monitoring with our vicinity diagram here. But beyond that, we have great ability to provide insight into your entire network infrastructure. So we actually use SNMP to go and auto-discover everything in your environment. So we talked about kind of that recursive algorithm to draw that diagram. We actually use the same recursive algorithm to go and figure out every single network component in your environment. Now, we can't draw all of those in the diagram. The diagram is limited to 5 hops, but this recursive algorithm will extend throughout your entire infrastructure. And it's going to be able to list every single networking device in your infrastructure. Now, since it communicates over standard protocols, it's also going to collect that information for every switch, router, hub, so that if you go and select one of them, it will tell you the manufacturer, the IP address ranges, what firmware version, basically all the different properties of that particular network component. So how is this helpful for continual availability? Well, a network component stops working, you just go to Operations Manager, and you have the full details of exactly every piece of that network component, down to the driver numbers. So if you need to call help, support, you have all of that information readily available to you in a single location. Now, Hyper-V virtual machine protection itself is done using Data Protection Manager, DPM. Now, DPM scales up pretty well now. It supports, or it protects our VMs, it protects our hosts, it protects our clusters, it protects our VMM servers. It supports Hyper-V running over SMB. So the new Hyper-V storage protocol, where you can go and store your virtual machines on a share, fully supported with DPM. It's fully protected during all types of live migration, storage live migration, shared nothing live migration, traditional live migration. It supports cluster shared volumes, version 2.0. It provides item-level recovery. And so what that means is, if I'm protecting an entire VM, and I only need to restore the configuration file, or I need to peek inside the VM and restore a particular folder, I have the granularity to do that with DPM. It's not kind of an all-or-nothing replacement anymore. And you also have the ability to restore things back to their original host, to a different cluster, even a different data center. So a lot of options with your backup solutions. Now, as we continue to back up, we have great built-in support for all of our primary Microsoft solutions, all of our main enterprise solutions here. And there's lots of different backup options to disk, to tape, to the cloud. And we're going to talk about this a little later, but DPM now gives you the ability to back up your information up to Windows Azure. So if you're running short of storage space, go push it up in the cloud. If you need to recover in a different location, pull it down from a different location in Windows Azure. But we wanted to extend this as well and have systems set to protect across data center level failures. Now, using the new Hyper-V replica virtual machine technology with Windows Server 2012, we enable replication across sites. So if you have a single server that crashes, we can fail over to a different server, fail back when it comes back online. If you have an entire site failure, we can go and recover on that secondary location and even bring it back online once the primary location fails. So System Center 2012, SP1, plus Windows Server 2012 gives you the best online, best availability solutions possible. Now with that, I'm going to turn it over to our first demo.
Great. Thanks, Simon. So looking back at exactly what Simon said, if you take the data center, and I like to call this the data center onion, if you will, if you start peeling it back and you look at what's comprised of the data center and how to make it continually available through Virtual Machine Manager, you have the first piece of storage. So as your storage is highly available, you're bringing it in through different arrays like EMC, NetApp, 3PAR, HP, some of those arrays that are brought in for the storage aspect. You can basically bring in all your storage arrays or into an aggregated platform through SMIS providers or SMP providers into Virtual Machine Manager. But you can also bring in your network load balancers and logical switches and create VIP templates around that. Once I've done this, I've actually gone ahead and broken things down for storage, network, compute. And I've actually gone ahead and built out my Hyper-V cluster. And I'm kind of talking through this because I'm going to show the VM capability. So as we get into the VM capability and deploying highly available virtual machines, the first thing that we have is a virtual machine template. And for my environment, I have a scenario. And the scenario is that I have a manufacturing firm, and this manufacturing firm wants to deploy a 3-tier application to their environment. That 3-tier application is going to consist of all highly available VMs, but also needs the templates to be highly available as they're deployed and have a load balancer behind that web application so that application is highly available and load balanced for the customers. So as I get into a template for virtual machines, I go into the hardware configuration and I scroll down, and I look at the availability. I got the processor memory and the hardware configuration, but now I have the availability. Once I check the box to make it highly available, this VM template, next time it's deployed through a service or through any kind of service template, will check to ensure that the host that it lands on is highly available. Whether that's a VMware cluster, whether that's a Hyper-V cluster, whatever that may be, it'll land on a highly available solution. And that's where I could set the priority of that virtual machine. Now that I'm done creating a priority and ensuring that that VM template is highly available, I can now move on to that scenario that I was tasked with. And that scenario is building out an application for ordering or for my manufacturing environment. As I go ahead and I create a service template, I can choose what type of service template this is going to be. If it's going to be a 3-tier application, a 2-tier application, for this case, I'll just say I'm going to start with a blank service template. But I do want to create a 3-tier application. So I'm going to start with my web server, and as I drag and drop this onto the canvas, this now allows me the capability to deploy this entire platform as a service. And I'm going to drag out my application server, next, and then I'm going to drag out my SQL server. So I've already gone ahead and made sure that my SQL server should be highly available. I'm going to scale this back. And now that I have this in place, I have a 3-tier application. Now what I want to do is I want to add a load balancer. And that load balancer can be a Microsoft NLB load balancer, which is your software load balancer, or that load balancer could be an F5 load balancer. So like if I have a hardware load balancer in my environment and that hardware load balancer is what's on my web tier that's allowing these applications to be highly available and load balanced, I can then go ahead and connect that up to this application. So whatever load balancer platform that is, I'm now going to go ahead and connect that in and configure the service template. So I've now created a connection with the service template. As this service template gets configured and deployed, I also have the capability of ensuring that this is going to allow me to scale. So once I check this box, this is true cloud fashion where it allows me to deploy multiple instances in the event that this environment needs to scale. So this ordering application now has the ability to be able to have customers come in through a load balancer, through the web tier, move into the app tier for the application, and then to the highly available SQL tier. And that then allows me to deliver that ordering application to our customers, which are external facing in our environment. If this ordering application towards the end of the quarter needs to scale out or grow out, I now have the ability to leverage those instance counts to say, leverage these instance counts or take a maximum instance count and start to scale this application out or shrink it down based on the usage.
Thanks. All right, well, we're going to move on now. We kind of covered our key infrastructure solutions, and that was a great example there, how you can quickly, readily deploy a load balancer, how you can easily scale up. And remember, this is all standardization, right? And we're going to talk more about standardization now and the importance of this. So when you saw the service template, what do we do here? We configured our front end, our business tier, our back-end database, and then load balance the traffic. Now again, the importance of this standardization means it's going to be guaranteed to be deployed the exact same way every time. Now the very first time you're going to set this up with the developer, you're working on how the configuration is done, it's going to take a little time, right? You want to make sure that it's done right the very first time. But once you've got it configured perfectly, it's repeatable. You're going to eliminate configuration issues, eliminate downtime, eliminate different problems that come with human error when they're deploying a service. The next key concept of service delivery and automation here is self-service, enabling our end users, freeing up time for our IT department. If somebody has a problem with a laptop, with an application, they go to our self-service portal, report the issue, we could go and address it much quicker. And finally, automation, tying these pieces together. Hey, self-service user says there's a problem, let's automate the resolution here. And we'll automate it using a standardized series of steps. Now, service requests for manual error reporting. Well, we have our data center admin. They get a problem that gets reported to them. Let's say their application needs to be scaled out. It's performing slow. Well, in the past, right, that might have been painful. You'd have to pick up the phone, and you guys are probably like me. I hate speaking to people on the phone, right? I'd rather communicate over email, or even better, I'd rather just get a form that I get to say approve or reject. That's essentially what we're trying to get down to. We're trying to simplify day-to-day operations for our IT guys. Reduce the back and forth, picking up the phone, asking questions, saying what's wrong. We just basically want to have the end user say, hey, I have issue 1, 2, 3, 4, or 5. It's issue 2. Okay, I always know how to fix issue 2. I have an automatic way to solve it. Use a template, use an automation activity, and get that done quicker. Now, also think, one of our goals here is to save you guys time, right? This means that you get to reinvest that time working on other projects, working on other services, adding more value back to your business. If you used to spend 1 day a week patching clusters, and now you have an automated way to patch them, not only will your clusters be more secure because they're always patched, guaranteed to be patched perfectly every time, but you now have that extra day that you could spend working on new projects, providing better services, providing even more high availability to your apps. So think about this automation as a way to better enable you to do more with less time. Now, with service monitoring and recovery, first of all, we talked about these application dependencies where we can break down a complex solution, look at all these different layers. But we also now have the ability to monitor these applications and layers, different depths. Now, with System Center 2012 Operations Manager, we added a technology called Application Performance Monitoring, APM. Probably heard about it in the keynote a little already. But this gives us incredibly rich insight into how an application is performing, down to the individual line of code. You could set thresholds that say, hey, my application needs to respond to this request in less than 5 seconds. If it takes longer, create an alert. This is, again, just tying this relationship with our developers back to our IT department to more quickly detect problems so that we can more quickly resolve them. Keeping our developers happy, keeping our IT department happy, keeping our end users happy, most importantly. Now, once we're able to get this data through application performance monitoring, again, we can isolate the root cause. In this example, we're actually looking at an individual SQL query that's come back as inefficient. That's pretty awesome that we could just automatically go through a developer's code, not be developers, and tell them this is the bad query that you used. I mean, most of you out there, if you're IT guys, you probably do scripting, but you probably don't do a whole lot of coding. This does the debugging in the code for you. This is saving you time. This is saving the developers time, so you can more quickly fix these problems and get the service running faster, quicker. Finally, we have connections that go and send these problems straight to Team Foundation Server. Think of Team Foundation Server as a developer's project management solution. Their project database keeps track of bugs. It keeps track of change requests. As soon as an issue is reported, we have the ability to automatically go and assign that bug to a developer, assign it to engineering. This is going to open up the correct bug in Team Foundation Server, assign it to the correct developer, and include all of that detailed information for them, simplifying the time to resolution and saving you time as well, right? You don't want to be going out there collecting stack traces for them and copying it and putting it in the bug database. We now do all of this for you. Now, as we're speaking of automation, we're going to be showing our System Center Orchestrator shortly. Now, Orchestrator is our automated runbook system. Drag and drop, click go, it performs a series of complex steps. Now, there's a lot of built-in integration packs for most of the core systems and services coming in Windows. There's also integration packs for every System Center component, as well as many third parties as well, included VMware, Windows Azure, not third party, but Microsoft, but then these third-party management systems. So this includes things like BMC Remedy, IBM Help Desk, Dell DRAC, HP ILO. Pretty much any automated solution you could go build a management pack for. Now, it's fully extensible as well. And what we mean by this is, if there's a way that we can programmatically communicate with the hardware, the service, the application, we can use it in Orchestrator. Orchestrator has a set of activities, these are those little drag and drop icons, to run a script, to run a VBS script, to run a command, to run PowerShell. Now think about what that means. Even if there's no activity that's built in the box for you, if you could type it in a script and click enter, and that happens, we can add that piece of the script into this automation activity. So as long as it's scriptable, as long as there's a programmatic interface, you can use it with Orchestrator. Now, this is also a recommendation that we have now as you start to think about future hardware investments. Make sure any future hardware investments do provide a programmatic interface for you. Now, the reason why, we want to be able to automate things right. Let's say you have a storage solution that requires you to go to a graphical user interface to configure it. Click here, click here, click here. You've carved a lot. Guess what? You can't automate that. That requires that manual interaction. You guys want to think about getting rid of anything that requires the click, 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 and manual interaction, because that breaks our automation. Focus on anything with a programmatic interface so that we can automatically carve out that LUN, automatically define a new software network. Let's go back to our second demo here and take a look at System Center Service Manager.
Thanks, Simon. So in the first piece, what we did was we basically put together our highly available infrastructure. We had our storage, we had our network, we had our clustered servers, we had our applications that were behind a load balancer. Now I think it's to a point where, you know what, that's a repeatable process. We do it over and over and over again. And that repeatable process, because it's there, and to provide more efficiency for a system to do it, you can now provide that automation through self-service and Service Manager. So in my Service Manager portal, I'm going to go through Data Center Services. And in Data Center Services, I'm going to go ahead and request a new highly available VM. And this new highly available VM request will allow me to go ahead and place this highly available VM in that service template that we configured earlier in Demo 1 and place that on any kind of service or any type of application environment that I want to prepare it for. So the first question that I have here is, please provide a description for the VM that you're going to use. So I'll say it's a financial server. And how many CPUs would I like? So I'll say I want about 64 CPUs. How much memory do I want? I want about 1 terabyte of RAM. And how much hard drive space would I like? I'm going to choose 1 terabyte of hard drive space. And I think my storage administrator actually went ahead and convinced my Service Manager administrator to put that piece in saying, I better be kidding if I'm actually requesting 64 terabytes of storage. But I'll go ahead and I'll select my operating system. And as I choose my operating system, I'm going to choose which type of hypervisor or the platform that I want to deploy it on. Whether I want it highly available in Windows Azure, whether I want it highly available in VMware, whether I want it highly available on a Hyper-V cluster, or even Xen for that matter. And then as I choose that platform, this system is intelligent through Orchestrator and has the ability to be able to automate where it needs to go. So I'm going to choose Hyper-V platform. And I want to say who's the business sponsor for this request. So I might say maybe Nate or maybe Duncan. And I'll say Duncan. So as I choose the sponsor, now I'm going to say I need this VM by today or I need this to be delivered to me, but in the same repeatable fashion that we organized it initially. So we put in the VM template, we made it all the SQL services highly available. I want this to be deployed to me by today with these approvers. Here's the information I need. This is what I need to get started. So as I submit this request, or as I go ahead and review this request, I'm going to submit it. And now that I've submitted the request, this request through Service Manager is going to leverage a connector in Orchestrator and kick that off. But first, this VM needs to be approved. So as I go into this request in Service Manager, this VM will now need to be approved in order for it to go ahead and be deployed. I'm going to scroll into this. And as this gets approved in Service Manager, this now gives me the capability to move into Orchestrator workflow. And that Orchestrator workflow is going to say, initialize the data of that request, grab the runbook information, get the service request, create the software relationship, and then the VM properties that I entered into that service request, go ahead and fulfill those. So this is the deployment location, the service name, the CPU, the OS, the high availability that I want it to go to, and then deploy that VM to either Azure or to my Hyper-V cluster, along with, if I want to deploy it to my VMware cluster, do that also. So that's what allows me to fulfill that service request through automation or through a self-service process, so that that first piece that I automated or that first piece that I set up with high availability can now be automated through self-service in a repeatable manner.
Thanks. Great example. I think one thing to add on to that, approval is entirely optional. If you want to fully automate this, have automatic approval, that's possible as well. So if you don't have to want to worry about, adding that extra time, of going through the administrative steps, automatically want to spin it up, fully support it as well. Now let's move on and talk a little more about our applications as well. Now we talked a little bit about application performance monitoring with self-service, but we also have application performance testing as well that comes as part of that. Now, what we want to do here with our applications is not just wait for an end user to report a bug, right? Oftentimes it takes a while for our data center administrators to realize there's a problem because a couple people report it. Most of them, a couple people, end users hit it. Most of them won't report it. You might occasionally find it a problem, a day or two later. So what we wanted to do is build in automatic testing as well for our applications as well. So what we could do is we could create server-side tests, where basically the server will try to run the application, make sure that it could be connected through our networks, through our storage. We provide client-side testing. With client-side testing, we will go and simulate an end user accessing the website, going through different things like different browsers. And then finally, we have synthetic testing. Now, synthetic testing is basically fully customizable testing. What you can do with Visual Studio is create a tracking utility that will actually simulate an end user testing a particular application. Let's say it's a website. You could go down to the level of detail of saying, clicks on the home, clicks on sign in, enters this username, enters this password, clicks enter. On the new page, opens a new you could actually specify these actual end user devices and automatically test them again and again and again. And so this gives you the advantage of not having to worry about someone externally finding the bug, hopefully finding out about it within a few days. You can test this as soon as you spin up a new application, ensure that it's healthy, ensure that it's running, and best of all, it's fully customizable. Now, we wanted to extend our monitoring as well. Not just run it in your own data center, but be able to monitor an application that you've gone and deployed up in Windows Azure as well. So we have management packs to actually go and monitor your Windows Azure services and apps. So if something's performing slowly, you need to buy a bigger disk, a bigger instance, Operations Manager can send the alert up, tell you when there's a problem. But now we extended it even further with Service Pack 1, Global Service Monitoring. Now, we kind of covered this in the keynote already, so we're going to spend a little bit of time on this, but not a whole lot. With GSM, we're actually going to monitor a website from anywhere around the world. We have 16 different data centers. We use different Azure data centers, and we will go and test your application from anywhere in the world, any of these 16 data centers. So why is this important? Well, most development studios, most customers, you have a single data center, right? Or maybe you have a couple data centers located within the same country. But if you're, let's say, a developer based in Moscow, how well does your application work from Sao Paulo? From Japan? From Australia? You don't know, right? What do? You go ask a friend to test it for you who happens to live there? Well, we wanted to fix all of that headache, all of that problem. We now have these 16 data centers around the world that will go and test your website, go and test your web apps for you, and report data. So if there's a performance bottleneck from a different part of the world, we'll alert you, we'll test it, we'll aggregate the results for you, display those results back in Operations Manager on your own console so you can see a rich display of how well your app's working anywhere in the world. And if you have the SA, the software assurance package as part of Microsoft, this is for free. If you don't, you can still get a trial version. And basically the only difference is the trial version has a limited number of tests you can use. The full version with software assurance, unlimited number of tests, unlimited number of scale. Do kind of what you want with it. So a great way to just ensure this application continual availability all around the world, no matter where you're based. Now, within an application, we kind of talked about having these multiple tiers already. We showed this in the first demo. This is really important, again, to emphasize this consistent application configuration. Now, we kind of just said, hey, front end, middle tier, back end, but what we can really do is go into a lot of depth in each of those tiers as well. So we can install the different services, roles, features for Windows. We can install our SQL databases, SQL DAC packs, include custom information such as usernames and passwords. We can install administrative passwords, set things such as local time zone, different administrators that have rights to that server, remote desktop connections. You could basically configure anything you want that's going to be in an application through Virtual Machine Manager. Now, with VMM, we have what are called profiles. Think of a profile as a template. So we have application profiles, which is how will a server app v template work and be installed. We have hardware profiles. What type of host should this service run on? We have guest operating system profiles. What's the guest OS? It could be Linux, it could be Windows, got a lot of flexibility there. But the point here is we have incredible granularity for installing all of these features. So when you're thinking about deploying a three-tiered application, multi-tiered application, and having those tiers be consistent, don't just think that the 3 VMs and the virtual networks are working. We could go down to incredible detail to ensure every single component is configured the same and deployed the same. Now, think about with a traditional environment, right? You go and deploy 6 VMs. You have to log into each of them, assign the usernames, passwords, SQL passwords, things like that. configuration mistakes happen. With this service template model, we can ensure that the service is deployed every time, so all of your passwords are working, all of your admins can access the correct server. So anytime there's a problem, we can go fix it immediately. But of course, since it's consistent, hopefully there won't be a problem. But now, we wanted to go a step further as well and make sure that maintaining and servicing these applications is easy. Now, a little earlier, we showed the scale out feature, right? Where you could go and select your application, say, I want this to be able to scale out. Now, what this does, it gives us the ability to go and service components with zero downtime. So think about let's say my front-end website, right? It's version 1.0. Our developer's done a bunch of updates. We've tested it internally. We want to go and deploy version 2.0, but without downtime. So how can we do that? Well, great thing about using these service templates is we could go and say, I have my version 1 running. I'm going to deploy version 2 side by side. I'm going to have a network switch. It's going to start redirecting our users from that first, version 1, over to version 2. I'm going to take down version 1, recycle all the resources, put them back in the pool, and we've actually done an entire in-place update for our virtual machine with zero downtime to any customers. This is in-place updating. You know, we could deploy load balancers, redirect traffic around. So you could service a VM or even a component within the VM with zero downtime for that entire service. We're going to switch it back over to our next demo here, as we're going to talk about some application performance monitoring.
So in this demonstration, we have a couple different scenarios. The first one being, like Simon said, patching. So in the event that servers are patched in the environment or even clusters are patched in the environment, a lot of times you see that the host comes back up, the VMs come back up, the operating system's back up, but the application's still not back up. And a lot of times that's due to either SQL coming up, last, or a different application coming up in a different order. And some of the challenges that we're faced with are really ensuring the availability of the application and the business level service, and not necessarily only the availability of the VM or the hardware service. So how many of you guys in your environment have applications that are not truly highly available at the application layer? So a lot of you. And in that kind of scenario, a lot of times after patching, what ends up happening, and this is a very common scenario, that the application itself is just really hard to troubleshoot when you get down to that layer. So what I have here is a distributed application. And with a distributed application, I'm going to go into this financial application that's really critical for my environment. I'm going to go ahead and I'm going to try to find out, after patching, what happened to this VM, or to this application service. And once this distributed application now shows up, I have this comprised of a 3-tier application. I have my databases, I have my web servers, and I also have a Linux application server. So I see, as I'm done patching, that these services or these systems are up, but the applications and the way that they work with the service are not necessarily up. So this financial application at the top is in a critical state. But my website's fine because my web server came up totally fine at the beginning. But my SQL databases, I have 3 of my databases from the reporting side for this financial application that are up, but my wallet application is not up because that application database is down or is still being recycled. And then on my Linux side, granted that's one of my application servers that's leveraging that database, I have one of the servers that is up, and then the other server that's not properly up or hasn't been properly recycled. And it's not because that server's been patched, but because the hypervisor that it was on, the server came up first, but the OS inside of it is still in a recycling state. So this allows me the visibility to be able to go right into that application from the top level down and say, you know what, this is exactly where my problem is, instead of having a call or having a conversation with multiple teams to figure out and troubleshoot the issue. Especially after patching, a lot of the remediation of these services can be done very effectively and very easily through leveraging things like distributed applications. So the next piece is, great, now I have this application up and running, but how do I ensure that it's accessed or can be accessed globally? And that's with GSM. Now, how many of you guys heard of the Global Service Monitor feature with Service Pack 1? How many of you guys have configured it? So I see one hand. So I'm going to show you guys exactly how easy it is to go ahead and configure GSM. The first thing is that if you go online, and you can start either a free trial, or if you already have an Azure account, you can set that up. So if I say I want to set up an account, I'll get prompted for my information, my email, etc. It'll send me a username and password. It'll set up my organization to be able to work with GSM. The next thing is I'll get the ability to be able to download management packs for Operations Manager. So now I have the Operations Manager management packs that will allow me that extensibility to be able to monitor with GSM. The next thing is, as I go into Operations Manager, I then set up a synthetic transaction. And that synthetic transaction could be for application availability monitoring. So I want to go ahead and do application availability monitoring. So I'm going to right-click and say I want to add monitoring. And this is going to be the synthetic transaction that monitors my services externally as well as internally. So if I have an application server or if I have a web server that's running internally, it'll allow me the ability to be able to monitor internally from inside my network as well as externally. And resolution is always a fun challenge. So I'm going to click Next. And I'll say, this is the MMS website. And this is going to be a live monitor from external. So I'll say MMS 2013 website. And the management pack that I'm going to put it in is my synthetic transactions management pack. I'll click Next. And this is where I'll say, here's what this service is. So this is the MMS 2013 website. And I'm going to take the link for that website that's external, and I'll copy that, and I'll put that in that synthetic transaction because I want it to monitor that link. Click Next. And this is where I have GSM enabled right with my synthetic transaction. So Global Service Monitor will allow me the ability to monitor it externally, and it's built right into the initial synthetic transaction. So now I can monitor it from the 16 external data centers across the globe and see how my site's reacting to that externally and not only internally to my environment. So I'm going to choose the Sydney data center. I'm going to choose Paris. And I will choose Chicago. So these are my 3 external locations that I want to monitor this website from. Internally, I want to monitor them from some servers internally that'll be leveraged as a watching service. So I'll say I'll use a domain controller, for example. I'll hit Next. And now you'll see inside of this configuration for viewing and validating this website, I have my external data centers as well as my internal data center. So I'm going to run the test to see how long it takes for me to access this from my internal data center back out and see how that HTTP request is returned. So yes, I see it was successfully accessed. I can see the full response and all the information that's associated with that, the timeouts, the seconds, etc., because this becomes really helpful for me. As I'm providing service to external clients, or even if I'm making that a website for my environment, and if that's my external public-facing website, I want to ensure that that's available not only within my internal infrastructure, because I can hit it internally through my servers, but I want to make sure that it's available from external locations, like these locations that I selected. And now I have a synthetic transaction that I can monitor from each one of these locations. And one of the really great things, and going back into application monitoring real quick, one of the really good things is as I monitor these services, or as I monitor my servers as a business service, this allows me the ability to look at and achieve the understanding of the availability of that business service or that application. I'm not only tied to the understanding of, hey, this server is up 5 nines or this storage system's up 5 nines. I now have the ability to be able to look at the application and say, this application's available for me with certain uptime. So in this diagram view, I can go ahead and quickly look at that application that I have, including my external global GSM monitoring, and I could generate an availability report on the right-hand side and see exactly how long or how available my application is for that environment, whether it's 3 nines, whether it's 5 nines, or am I really delivering that SLO.
Excellent, thank you. Now we're going to talk about, very briefly, how we can extend our solution using Windows Azure. Now we talked a little bit about this earlier. I gave a few examples such as monitoring, but I'm just going to try to give a all-up view here now. Now, first of all, we want to think about actually moving and managing our VMs. System Center App Controller allows us to actually go and deploy our VMs to different locations. Now, I can have a developer, one of the big advantages about the Microsoft Cloud is our consistent set of tools. That's Visual Studio for our developers, Hyper-V to deploy VMs, System Center to manage, and Active Directory for identity. But with App Controller, we can have a VM that our developer creates, customizes, deploy that on-premise, deploy that to a third-party hoster, deploy that up to Windows Azure from a single interface. So let's say I have the developer who notices that, hey, his application's performing slowly. It's the weekend, no one there's to help. He could go deploy it up into Azure and has no requirements for needing to have on-premise infrastructure. We then have the ability to go and manage our infrastructure or manage our VMs, even if they're in different clouds. App Controller allows us to monitor the health of our services and applications. Data Protection Manager allows us to back up our resources from on-site up into Windows Azure. And Orchestrator has its own Windows Azure integration pack, meaning that we could go deploy services, spin them up, spin them down, add disks, remove disks, fully automated, whether it's on-premise or up in Windows Azure. Next, we have the ability to monitor our applications. Again, App Controller tells us the health, tells us security. Operations Manager will detect things down to performance level. Is our app performing fast or slow? And finally, we could use Azure as our cloud-based service to go and scan our entire environment, report the information back as far as what's healthy or not. Now, we saw this slide earlier. I'll kind of advance into a little bit because I just want to highlight the final thing here as we jump into our last demo, backing up to Windows Azure. So I'm going to turn it over to you and let you jump into the details of this one.
Okay, so for backing up, there's a lot of different scenarios where you can back up to tape, back up to disk, back up to offsite storage. And a lot of times, some of the key things that are brought up in front of our customers is, well, I want to kind of be able to get rid of tape. I want to be able to take the backups that I have and have them, come to my on-site disk for my on-premise storage for 7 days retention, but I want the rest of it to go ahead and be sustained in the cloud where it's out there and I don't really necessarily have to worry about offsite tape. So at this point where I have DPM, along with that account that I set up earlier, where I showed you how you set it up in GSM, you have the same exact type of account that you can use for DPM and register that. And this is where I'd manage my subscription and I'd configure that account. So the registration, the login, everything that I got from signing up in that account, I can go ahead into System Center and now provide that integration. What I'm going to do is I've already gone ahead and set that up. I'm going to create a protection group around a VM. And that protection group is going to allow me to be able to back up a VM on disk and on-prem as well as offsite in the cloud in Windows Azure. So I'm going to choose servers as the type of protection group or the type of device that I want to back up. And I'm going to choose a virtual machine on one of my Hyper-V hosts. And as I select this virtual machine, or as I choose which one I want to back up, I'll get two types of retention policies. One for disk and one for online. So now I have that ability to be able to back up online. So with that extension, or by putting in that management subscription, this allows me to be able to get online protection. So my short-term recovery will be to disk, and my long-term recovery will be to cloud. So I'll call this MMS demo for my protection group. And I'll say my disk retention I want for 2 days. I want to back up every day at 6 p.m. I want to automatically grow the volumes. I want this to go over the network, now or later. And let's just say I want to schedule this at 7:53. I run a consistency check in case the replica becomes inconsistent. And now I want to go ahead and take this and I want to back this up into the cloud. So this is what I want to protect online. Now this doesn't necessarily have to be all my VMs. So I can have particular low-hanging fruit VMs that I want, that I can have them backed up onto disk and then say, you know what, the retention of this just needs to be 5 days or particularly 7 days, or just applications, things that I don't necessarily need to back up, like development environments. Or if I have something that's critical, I can go ahead and back it up online. I'll click Next, and I'll say I want the retention for the cloud to be a lot longer. I want this to be 7 days, or I want this to be 365 days, or even 3 years, or 7 years, or whatever it is. And I'll choose the time I want it to back up. I'll select Next, and I'll go ahead and I'll create the backup group. This will allow me the ability to go ahead and bring this up into my data protection environment onto disk, along with the data protection environment in the cloud.
Excellent. Thanks. So a lot of great solutions as we've seen on-premise and using Windows Azure. Finally, some additional details about System Center Advisor, our cloud-based service. Now, I kind of gave you an overview, but I think what's really interesting is some of the history behind it. Now, System Center Advisor, it's been a project, it was called Project Atlanta. It's been happening for about 3 or 4 years. Now, all the engineering teams, I used to be on the cluster engineering team, so I kind of helped contribute to this. All of the engineering teams worked with product support to figure out what are their top 10 most painful customer issues, top 50 most painful customer issues. And then we said, which one of these can we automatically detect and easily resolve? And so we worked with the SQL teams, we worked with the cluster team, the Hyper-V team, the Exchange team, the Link team, and the, what's our other big server? SharePoint, thank you, the SharePoint team. I'm an infrastructure guy, I don't know the SharePoint stuff. So we worked with all these different teams, worked with product support, and we figured out what are all the major customer issues. And a lot of them just came down to misconfiguration or missing patches. And so as we kind of think, what's the configuration? What's a patch? How can we programmatically detect if a customer has that or not? We realized, hey, you could go scan through the registry. You could see whether certain patches are installed in the registry, what settings people have, what roles they have installed, what features they have installed. So we figured, wow, putting all this information together, our most common customer problems, missing hotfixes, missing patches, easy way to detect them. We can save you guys a lot of time, a lot of money, and a lot of pain by just having an automated system to scan your server, figure out what roles and features you have installed, figure out what settings you have correct, what you don't, what patches you're missing. So think of this as almost a best practice analyzer in the cloud that's built from our own product support database, our own product support engineers, where we're delivering this to you as an easy way to solve your own problems. So that's essentially what System Center Advisor is. It's going to go, you go and download it, go install it. If you have Operations Manager in your environment already, it will use the Operations Manager connector. If you don't, it installs a lightweight connector. And basically, it goes to all of the servers in your environment, scans them, collects the data, puts them, aggregates everything to a single reporting server that you specify, pushes everything back up into Windows Azure. Then you go to a website, and you can see what's working well, what's working great. But not only does it tell you the problems, it also tells you how to fix them as well. It will say, you're missing this KB article. Here's the link to download it. And you need to download it and install it on all of these servers. Hey, you have this wrong setting for Hyper-V. Here's how to change it. Go change it on these servers. So think of this as just an end-to-end best practice analyzer for all the key Microsoft components. And best of all, it's completely free. Now, there's been some consultants out there that are like, oh man, this is kind of hurting my business, right? I'm the guy out there that goes and tells them about these best practices. But think of it this way. You can now become a System Center Advisor expert. What you have the ability to do with System Center Advisor is you are not locked in to one data center view. You can sign up and you as an individual can manage multiple data centers, multiple different customers from a single dashboard as well. So you can actually become a System Center Advisor consultant. Lots of small businesses, they don't understand really the details of patching and how to change these settings. But if you say, hey, go and install this, sign up for this, send me the data, I'll go analyze it for you, I'll go fix it for you. And it's also making your job easier. So consider System Center Advisor as a just good way to keep your environment healthy, keep it running, using a lot of best practices that Microsoft's built over the last decade. Now, as we wrap it up, I hope you learned a lot about different types of high availability options, continual availability options. There's a lot of things you can do. There's not just one solution that fits all. But as you combine all of these different System Center products, consider our cloud-based services with Advisor, with Azure, you can really maintain this continual availability from initial deployment with standardized configuration, constantly monitoring it and backing up that data, providing self-service so people can easily report problems, solve them themselves. And of course, automation, just to keep things running. Reduce time that you're spending fixing repetitive problems so you can free up your time to improve the services, do more with less. Essentially, as we put all these pieces together, our goal here is to provide you with the best Cloud OS environment, best availability, and in fact, not just high availability, but continual availability. Now, as I wrap up here, I want to point you to a few resources. First of all is the Microsoft Virtual Academy, www.microsoftvirtualacademy.com. We have a ton of courses that are free and public that will walk you through the different high availability solutions and the different System Center components. Finally, we have we're running out of time, we're ending right on the minute, but we're going to stay around for about 15 more minutes to answer any types of questions that you have. Initially, we will ask you to come to the microphone so that we can record them for our customers. After that, we'll be around, we'll stay around. I also have another fellow evangelist up front, Georgie. Wave your hand. He'll also address your questions as well. And with that, I hope you learned a lot, and I hope you can keep your services continually available as well. Thank you. So any questions? If you do, if you don't mind coming up to the microphone. If you want to wait, no one comes up to the microphone, we'll just take them down here. Don't be shy, we don't bite. And please fill out an eval, only if you like the session. You don't have to if you didn't. All right, well, we'll take questions up front, so don't worry about the microphone. If you have any questions, please come down. Happy to help you out.